Welcome to the Group 9 Design and Synthesis Project presentation of the Ghanaian Modular Earth School. The Learning Curve Co. is a group of 7 undergraduate civil engineering students at McMaster University. They partnered with Schools of Dreams, a Canadian-based NGO dedicated to building schools in rural Ghana, to design a basic school in Kwachakrum, Ghana. The students involved in this design project are Kapin, Bennett, Bahavish, Prithvi, Marco, Yasmin, and finally Ashvin. The Schools of Dreams contact information are available on the slide. The scope of this project was to design a basic school to be built in Kwachakrum, Ghana due to a lack of physically adequate schools in the region. A basic school encompasses kindergarten, primary, and junior high school grades. The main goal for the design is for the school to be modular, self-sufficient, and sustainable while providing ideal learning environments. The idea behind a modular design was to create multiple structurally independent units repeating once or more throughout the school layout. This is specifically advantageous for communities with rapid population growth as it allows for a gradual development of the school. It also saves the client future costs associated with design for other projects they wish to undertake and the flexibility to select specific modules based on the demand. The comprehensive design for the Ghanaian Modular Earth School was split into 8 chapters addressing 10 main design deliverables, which are architectural modules in a school layout, a flexible asphalt pavement parking lot, an unpaved gravel roadway design, vegetated bioswales for stormwater runoff management, rammed earth walls and floors, corrugated metal pitched roofs with solar panels, cross ventilation and powerless air ventilation technology, a wood roof truss design, a wood framing design, and finally a strip footing design. 3D models of certain sections of the school were produced and can be seen here.
Design choices were made along every aspect of the design project to achieve the right balance of environmental, social, and economical sustainability. Some key sustainable choices are a communal garden where non-potable harvested water is used, a gym space or library that can be used by the community after school hours or weekends, solar panels to allow for energy self-sufficiency, powerless ventilators on the roof to reduce energy consumption due to ventilation demand, and lastly, thermal rammed earth walls and floors which allow for 100% natural ventilation and are 100% natural earth material, thus minimize environmental impacts during construction and past its lifetime period. Lastly, it is aesthetically pleasing and it gives a unique feel to the structure.
As was demonstrated in the previous slide, there are numerous innovations in this project, with natural materials to modularity, and an additional one we wish to highlight include the passive cooling technique, which utilizes the natural direction of the wind and wind ventilators on the roof to create a natural cyclical ventilation system in each module. In terms of challenges, our group faced challenges in gathering information, as texting through WhatsApp is the only method of communication to reach people in the community, so ensuring that each design decision was communally relevant was not possible and thus posed a limitation. Balancing budget with innovative design and receiving reliable cost information on labor and materials was also very difficult. In this chapter, the site was to be chosen and information on it gathered. The site in Kwachakrum was chosen as per Schools of Dreams' request for their future project, and so our team researched to find all relevant site information, such as the slope, surrounding area, land use, soil type, as well as the climatic conditions and available utilities, which are shown on the slide. All of this information was gathered through online research or conversations with Schools of Dreams, and it was crucial to determine if this project was feasible, which it was found that it was.
During the architectural chapter, the Ghanaian basic school curriculum was studied to come up with the required school components. Component dimensions were then estimated based on Ontarian standards. Having the component dimensions, 8 modules were produced. The respective number of units of each module was decided based on the enrollment projections up to 10 years. Finally, a school layout was created to encompass all the units required for the school.
In this chapter, we talk about how resilient and effective water infrastructure tends to be crucial for both environmental and public health. We discuss the design for water supply, water treatment, water storage, and flood prevention. Throughout this chapter, sustainable practices such as rainwater harvesting, reusing, recycling are taken into practice.
In this chapter, feasible and economical designs were created for the external walkway, the school parking lot, and the internal walkways. The external roadway will be an unpaved gravel road with the structure as seen below on the slide. It is designed to maximize drainage and be inexpensive. The parking lot is designed to carry minimal loading, and a flexible asphalt pavement provides for great strength, durability, and reduced cracking. Lastly, the internal walkways were designed using existing materials on site to create earth flooring.
One very important aspect of the school is that it is built with rammed earth. The material is inherently insulated and has sound insulating qualities which make it a perfect wall for classrooms and educational facilities. We decided to use solar panels to save electricity costs by using less energy from the grid. For natural ventilation, powerless air ventilators were used along with full-width operable clear-story windows added on the back of every module to allow the hot air to escape.
For the structural design chapter, the design loads were determined using the National Building Code of Canada handbook, and each module was designed to sustain the effect of these loads. Wooden framing was used as all the modules are single-story structures, and Ghana is home to one of the strongest woods in the construction industry, Odum wood. Modular connections are installed along the exterior members to allow for a flexible design and easy additions to the school as the enrollment expands in the future.
For the foundation design, concrete strip footing design was selected. It reduces construction time during excavation. It transfers rammed earth wall, dead load, and wood frame loads to the soil. And finally, the stem wall supports grade slab from settling. As for connections, heavy-duty anchor bolts connect the bottom plate of the wood frame to the concrete, and hold-down anchors connect the columns to the bottom plate and concrete to prevent overturning due to lateral load.
In this chapter, we discuss construction planning, duration, limitation, life cycle analysis, and cost estimates. Social and economic sustainable practices were adopted for the welfare of the school, for example, solar panels, renting out space to the public outside of school hours, bicycle lending programs, etc.
We are incredibly excited for the next steps of this project, in which Schools of Dreams has agreed to hire members of the design team for the real-world complete design and construction of the project, which we predict should be constructed in the following 3 to 5 years. On behalf of the Learning Curve Co., thank you for listening to our presentation.